Okay, we need to finish up the lever handle here. We've made the loft, which is the hardest part, but we still have a few more features to add. We have the little round end here of the handle. Let's go ahead and do that. I can place a sketch on the YZ plane. Let's slice graphics to remove the part of the loft that was blocking my view, so I can now see my sketch plane. And let's start by putting just a couple circles here, not too worried about their size because we'll constrain them to get them to fit. The inside diameter is 10. And the outside diameter is 20. I'll finish that sketch and do an extrusion. Select my profile. I don't want it to extrude all in just one direction though. I want it to go out in both directions equally. So I want a symmetric mid-plane extrusion, and the total width of that is 9 millimeters. So there's the round end. So part of my lever handle is kind of where it shouldn't be. So I suppose I should probably get rid of that with another sketch I'll put right here. And all I need to do is project the geometry like that. Projected geometry is already fully constrained, so I don't need to do anything to that other than finishing the sketch, creating my extrusion, except I don't want to add new material. I want to cut away old material, and I want it to go all the way through the part. So I'll click that, and now that part of the loft has been removed from the center of that cylinder. Next, I'll add the cylinder down here, which could be done as a series of 4 extrusions, but I prefer to do it all in one step by doing a revolve. So I will place my sketch, my 2D sketch, on the XY plane. Again, slice graphics, or you can hit the F7 key to slice these graphics. And I want to draw this part down here. All I have to do is draw the top half of it, and then I will revolve it. So I'm going to change my line type to a center line and draw a line from the origin off to the right here, some arbitrary amount. Doesn't really matter. Turn that center line feature off to go back to drawing regular lines and start sketching. Again, don't worry about the exact size of this stuff. Some of it we can, well, it's not going to let me infer that, so I'll just draw this over, up, over, down, over, down, over, down, like that. Not worried right now about the size. I'll come back and add these sizes. I'll just start at the left and work my way over to the right. The cylinder over here has a diameter of 14. Because I used a center line here rather than just a regular line, when I put a dimension to that center line, it automatically gives me, oh, I have an inferred constraint there that I don't want. Sometimes that happens, so I'll delete that line and draw it again, this time without inferring any constraints. Let's trim that off there and make coincident the end of this line, the end of that line. Nope, I moved it the wrong way. Might have to delete that line as well. So an inferred constraint is, like if I were to start drawing my line right here, that little dotted line that shows up as I place it, like is in line with this axis. if I click right now, Inventor is going to assume that I want that to be constrained to that line. And oftentimes inferred constraints are beneficial, but sometimes we accidentally include them when we don't really want to. So now I can place a dimension here and change that to be 14, and that is what I want. So I've got a 14 millimeter diameter here, and then that transitions to a 28 millimeter diameter for this feature. I guess I'll just leave the dimension over here, 28. Then it steps back down to an 18 millimeter diameter. And then finally the last step down is a 12 millimeter diameter. Okay, so I've got my diameters. Now we need to look at the lengths of these. From here to here, it is 22. This feature has a width of 7. The next step down has a length of 28. And the last one, 24. Okay, so I've got a fully constrained sketch, which I can now use to make a revolve. So I will revolve. It automatically chooses the profile for me and the axis, and it's a full revolve. I just have to hit OK. So that lays down the basic shape of it. Now, there is supposed to be a fillet on this side with a radius of 2, but I don't need to. I didn't need to create that in my sketch. I can make that as a 3D feature. I can select the 3D fillet command with a radius of 2. That happens to be the default. I just need to select the edge and apply it. Okay, so that rounds off that corner. I also have a couple chamfers here of, what size are those chamfers? It looks like they are 1 millimeter by 45 degrees. Let me show you what I'm looking at here. 1 by 45, 1 by 45. So those go on these two edges. So I'll select chamfer. Just make it a 1 millimeter. The first option here are equal legs, which translates into a 45-degree chamfer. I just need to choose my two edges and apply it. So now I've got the two chamfers. There is a hole in the side of this that looks like it's a through hole. So since it goes all the way through, I can just place the sketch on the XY plane. Now, if this hole had any kind of special features like threads or a countersink or a counterbore, I would want to place this as an actual hole. But since it's just a plain through hole, it's okay to just make it as a cut extruded circle. The distance from this edge to the center of the hole is 20. And the diameter of the hole is 3. And I can make a horizontal constraint between that point and the origin. That fully constrains it. Then I can do a cut extrude. Okay, it automatically chose my hole for me, but it's only making it cut extrude in one way. I want it to go both ways, and the distance is just all the way through. There we go, I've got that hole. And then finally I have this slotted hole that is not a through hole. It has a depth of 3.5 millimeters. So I want to place this the sketch on the side of this cylinder, but since the cylinder is not a plane, it's curved. In order to place a sketch on that plane, I have to create a work plane. This time I'm going to go tangent to a surface and parallel to a plane. I'm going to be tangent to that surface and parallel to the XY plane. So now I can draw the, I placed the work plane, I didn't place a sketch. Let's place a sketch on this plane. Now I can come in here and draw the slot. Okay, and the distance from the end of this cylinder to the edge of the slot is 3. And from here to there is also 3. And the width of the slot is 6. Okay, that didn't quite fully constrain it, so let's try moving it. It moves up and down. So let's apply a horizontal constraint between the origin and the center of my slot. Now it's fully constrained. I'll finish the sketch and do a cut extrusion with a depth of 3.5 millimeters. And again, I don't like seeing work planes, so let's make that invisible. And I think that's it. I think that covers everything. This is now a complete lever handle. Some people have been asking about these lines right here, and I believe they indicate the presence of threads. But the thread size is not specified in the drawing, so we could potentially add threads there, but I would just be guessing at what the size of those threads are, and I'd rather not do that. So since I don't know the size of them, I'm just going to omit them from this model, and you may as well. So if you get the loft, the extrusion, the revolve, the through hole, and the slotted hole down here, the slotted blind hole, then also the chamfers and the fillet, that would be a complete part. So if you've made it this far, congratulations. As I said, this is probably the most technically challenging part we will make this semester. You should have mastered now all of the 3D modeling creation tools that will allow you to model just about anything.